Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to go through question number 6 from the October 2023 Pure Mathematics P4 International A-Level Edexcel this exam here. And this question number 6 is about vectors, and we're told about the line L1, which has equation r equals 2, 3, negative 7 plus lambda times 1, 2, 2, where lambda is a scalar parameter. And the line L2, which has equation r equals 2, 3, negative 7 plus mu 4, negative 1, 8, where mu is a scalar parameter. Given that L1 and L2 meet at the point P, state the coordinates of P. State the coordinates of P, 1 mark. Now, many students will go about this question doing something completely unnecessary and ending up with an answer which they should have, when they get it, they've wasted like quite a few minutes, and they'll realize, oh, I could have just wrote the answer down. Okay, because we should understand what the equation of a straight line in vectors is made up of. You have the part which is multiplied by the parameter, which is the direction of the vector, and we have the part which is on its own, which is basically the position of a point on the line with respect to the origin. So as we can see here, the position vector of a point on this line and the position vector of a point on this line are the same. They both pass through this point. They must both pass through this point. So the coordinates of P are simply going to be 2, 3, and negative 7. This is the position vector of a point which is on both lines. O to P is the vector 2, 3, negative 7. Okay, therefore the coordinates of P are 2, 3, and negative 7. And that's as simple as that. We don't have to do any calculation. Now, some people would go and they'll put 2, 3, negative 7 plus lambda times 1, 2, 2 equals 2, 3, negative 7 plus lambda times 4 minus 1 and 8. And they will form 3 pairs of equations. They'll say 2 plus lambda equals 2 plus 4 lambda. And they'll say 3 plus 2 lambda equals, and so on. They'll have 3 sets of equations, and they will solve one of them and find the value of lambda from one of them. Mu, that would be mu. Okay, so that would be mu, 4 mu. Right, so they'll have basically 3 pairs of equations which are simultaneous equations. They would use 2 of those to find the value of lambda and mu and see if those satisfy the third, and if they do, that means that they intersect, and then they would use one of those values of lambda and mu and find the point at which they intersect, and they'll realize in the end they'll end up with this point anyway. Okay, so when they've done all of that, they'll end up with this point anyway. Okay, so you don't need to go through all of that palaver. Okay, in this particular question, if those were not the same, yes, of course you would do that method. You would equate them. You would make 3 sets of equations, some with lambda. The ones on the left will have lambda, the ones on the right will have mu. You choose 2 pairs of them, 2 of them, find lambda and mu simultaneously. If that value of lambda and mu you found satisfies the third one, they intersect. Okay, and in this case, because it says given that they meet, you would just choose, once you found one of them, lambda or mu, you would take that and put it into the relevant equation, and that will tell you where they meet. Okay, but in this case we don't need to do that at all. We can just put the values down of this point, which is the same, they both have the same position vector, they meet at that point. If the direction vectors were the same, then we can't say they meet at that point. That's not a point, that's a direction. That would tell us that they're parallel, but it won't tell us that they meet at the same point. These being the same means that they meet at that point, because this is a position vector of a point on line L1, and this is a position vector of a point on line L2, so they both pass through the same point. Okay, so I hope that you understood that. And now we're going to go on to part B. So then it says, given that the angle between lines 1 and line 2 is theta, find the value of cosine theta, giving the answer as a fully simplified fraction. So here we're dealing with the angle between the 2 vectors. Okay, so let's say you have line 1 like this and line 2 like this. Okay, so line 1 is going like this, say line 2 is going like that. This is the angle between those 2 vectors. Okay, and what we should know, or we should have understood, is that the dot product between two vectors is equal to the product of their magnitudes times the cosine of the angle between them when they are placed tail to tail. So if you want to find the value of cosine theta, okay, we have to use this formula. All right, so let's call now, what do we use from these vectors that tells us about their direction? It's going to be this part. We don't use the position vector part, we just use the direction part. So if we want to, we can say let's call A 1, 2, 2, and let's call B 4, minus 1, and 8. So we're going to find the dot product of A and B. That's going to be when you multiply them together, and this is how you find the dot product. I'll just show you here. You have 4, negative 1, and 8. So the dot product of these two vectors is going to be when you multiply the I components. So it's 1 times 4 is 4. You multiply the j components, 2 times minus 1, plus, and you multiply the k components, 2 times 8. So you end up with 4 minus 2 plus 16, which is going to give you 24 minus 2, which is, 20 minus 2, which is 18. Okay, so that's the dot product of the two vectors. And then we need to find the magnitude of the two vectors. So the magnitude of A is going to be the square root of, now A is 1, 2, 2, that's going to be 1 squared plus 2 squared plus 2 squared. That's going to be 4 plus 4, which is 8, plus 1, which is 9, the square root of 9, which is equal to 3. And the magnitude of the vector B is going to be the square root of 4 squared plus 1 squared plus 8 squared. We don't have to worry about the minus sign because it's going to be squared anyway. That's 16 plus 1, that's 17 plus 64. 17 plus 64, isn't that 81? That's 81. So the square root of 81, which is 9. So therefore we can say that the cosine of theta is equal to, if we rearrange that, it's the dot product A dot B over the product of the magnitudes of A and B. So we can say cosine theta is equal to 18 over 3 times 9, which is 27. Okay, so we can say theta is equal to inverse cosine of, what goes into both of these? 9 does, doesn't it? That's going to be 2/3. Okay, so inverse cosine of 18 over 27. We are in degree mode, good. So inverse cosine of 18 over 27. That gives us 48.1896. So cosine theta is 48.1896. So we want the answer in, okay, they didn't tell, oh, sorry, find the value of cosine theta. So we have to be very careful here. I didn't read the question. Wasted some time. All right? And you don't want to waste time in the exam. So please, don't do what I just did there. Okay, of course I did it just to highlight to you that you shouldn't do that, but find the value of cosine theta, giving your answer as a fully simplified fraction. So you want to find the value of cosine theta. They don't want the angle, they want the cosine of the angle, but as a simplified fraction. Okay, so we have to just write this as cosine theta equals, as we mentioned, both of these, 9 goes into them, 18 divided by 9 is 2, 27 divided by 9 is 3, so cosine theta equals 2/3. That's what they want as the answer. So please make sure, reading the question, sometimes a few seconds will save you a few minutes. All right, because if you went ahead, we went ahead, we tried to find the angle. What the angle? Do we have to round it to 1 decimal place? Sometimes you might just write the answer down, think you've answered the question, and you will definitely lose marks for that. You'll definitely lose 1 mark if you left it as this and then you put the angle down, or even if you found out the angle in the end. Sometimes they say ignore subsequent working, or sometimes they don't, but most of you would not have put 2/3. They would have left it as 18 over 27 in their steps, and that's not fully simplified, so you would definitely lose a mark even if there was ignore subsequent working. So be very careful not to lose marks. All right, so there's 2 points here where you could lose marks by not reading the question carefully. One of them is by not lose marks, lose time, especially the first one, lose time. You would go by the general way of finding where 2 points, lines meet by equating them, making these equations and so on, that would waste a lot of time here when you can see that they meet at the same point. There's a question like this that came up earlier, I think in maybe one of the C3-4 papers, and I remember giving it to my class, and I remember seeing the majority of them waste their time making those equations, and just one or two of them realizing, oh, they actually meet at this point. So you go into auto mode without just like robotic mode. Oh, we have to find where two lines intersect, we have to equate them without using your brain. Always think these are the same. Hold on, these are the same. What do those represent? They represent a point on those lines. So if those lines intersect at a point, that must be the point. Anyway, that's a bit of a diversion. Now let's go on to the next part of the question, which is part C. So it says the point Q lies on line 1. So we've worked out a few things. We have two lines, line 1 and line 2. I don't know how they go, but this is the point P. Let's say this is line 1, let's say this is line 2. Always with vectors, draw diagrams. Very, very important to draw diagrams. The angle between them is theta. We know that the cosine of theta is equal to 2/3. And I know that it's an acute angle, for sure, because it's going to be in the first quadrant. Okay, so it's going to be an acute angle. So if it was an obtuse angle, then that would be a negative. Alright, so and remember, this is always the angle between them when they are tail to tail, like this. Okay, so that's line 1, that's line 2, that's theta. And that's cosine of theta. Now it says the point Q lies on line 1, L1, where theta equals 6. So where lambda equals 6. So this is a point on both lines where lambda equals 0, and here where mu equals 0. That's where you'd have this point here. But we got a point Q. Let's say it's over here on line 1. Okay, let's say this is our origin. In fact, I'm going to make a bit of space. So let me just get this a bit more down here. I'm going to make a bit more space. Okay, so let's say that we have the origin, say, over here. This is O. Okay, so it says, given that point R lies on R2 such that the triangle QPR is an isosceles triangle with PQ equals PR. Alright, so there's a point R which is on this line, line 2, such that this distance is the same as that distance. PQ and PR are the same distance apart from each other, okay? Because this is an isosceles triangle. So we have an isosceles triangle, okay? And this length and this length are the same length, okay? So this is the point, this is OQ, right? And I can work out what OQ is. O to Q is going to be when lambda is equal to 6. So O to Q is going to be 2, 3, negative 7 plus 6 times 1, 2, and 2, which is going to be 2 plus 6, which is 8, 3 plus 12, which is 15, and minus 7 plus 12, which is going to be 5. So we can say O to Q is the vector 8, 15, and 5. That's the vector from O to Q. Alright, so we want to find the exact area of this triangle QPR. Alright, so how do we find the area of this triangle? Let's have a look. I know this angle. If I find the length of this line, PQ, and I find the length of this, that will be the same as the length of the line PR, I can use the area is equal to a half AB sine C. Alright, so I can find the length of PQ and the length of PR. I will have found my answer. So all I need to find is the length of PQ. Alright, I need to find the length of PQ. Right, so I know the vector O to Q. I know the vector O to P. So O to P is basically the position vector of P, which we know. So let me write that down. Okay, so O to P, we know the vector from O to P is 2, 3, negative 7. 2, 3, negative 7. So what I can say here is O to Q is equal to O to P plus P to Q. right? O to Q is O to P plus P to Q. I know what O to Q is. I know what O to P is. I want to find what P to Q is. So if I rearrange this, I can say P to Q is equal to O to Q minus O to P. Right? If I want to find what P to Q is, it's going to be O to Q minus O to P. So O to Q is what? O to Q is what we just found. 8, 15, 5. Minus O to P, which is what we know from the beginning, 2, 3, negative 7. So that's going to give me 8 minus 2, which is 6, 15 minus 3, which is 12, 5 minus 7, which is also 12. So this is the vector from O to Q, 6, 12, 12. So I know now, let me just I now know that the magnitude of P to Q is given by the square root of, this is P to Q here, 6 squared plus 12 squared plus 12 squared. Okay, so that's going to give me what? Where's my calculator gone? So we're going to have 6 squared, the square root of 6 squared plus 12 squared plus 12 squared. That gives us 18. Okay, and we know that the magnitude of P to R is the same as the magnitude of P to Q, which is also 18. So this length is 18, this length is 18, and we know the cosine of this angle is 2/3. So we have something like this. We have an isosceles triangle. Okay, we know this angle is, we know the cosine of this angle. We know this is 18 and we know this is 18. So if we know that the cosine of theta is 2/3, then we can work out what the actual angle, the sine of the angle is. We need to know, we need to use the sine of the angle. So we can draw a right angle triangle. We can call this theta. Cosine of theta is adjacent over hypotenuse. So this is going to be the square root of 3 squared minus 2 squared, which is going to be equal to 9 minus 4, so the square root of 5. So we can say therefore that the sine of theta is equal to opposite root 5 over 3. Okay, so therefore we can say the area is going to be a half AB sine C. So it's a half times 18 squared times the sine of theta, which is root 5 over 3. Okay, and it says find the exact area, so we want to leave this in exact form. So we can work out what this is and write it in exact form. So we have here 0.5 times 18 squared times root 5 divided by 3. And that gives us an answer which is 54 root 5. 54 root 5 square units. So there is the answer to this question, part C. The exact area of the triangle QPR. And then the last part of the question says find the coordinates of the possible positions of the point R. Alright, so R could actually be here, or it could also be here. Alright, because that would also be an isosceles triangle. Okay, and that angle would, the sine of that angle would have been the same as the sine of that angle, and that length would still be 18. So R could be in either of these two places actually. Okay, it could be also here. Alright, so this angle would also be theta. Okay, no, this would be 180 minus theta, which is the same, the sine of that angle would be the same. So it would be 18 times 18, a half times 18 times 18 times the sine of 180 minus theta, which is the same as the sine of theta. Because we know that the sine of an angle is equal to the sine of 180 minus the angle. So that would give us the same triangle basically. So R could be in either one of these two places. Now what I know is the magnitude of P to R is 18. Okay, so we know the magnitude of PR is 18. And I know that the vector P to R, okay, is something which is in the same direction as line L. Okay, it's in the same, so it's a multiple of, okay, P to R is some multiple of the vector or the direction of line 2. Line 2, so it's line 2 is going in this direction. So we know that P to R must be some multiple of this vector, because when two lines are parallel, two vectors are parallel, they are multiples of each other. So it's going to be some multiple of 4 minus 1, 8. Okay, so 4 minus 1, 8. So we can think of this in two ways. I could find the unit vector for this vector and then work out 18 times that unit vector to give me the vector that I'm looking for. Or what I could do is I could say that I know that the magnitude of this PR has to be 18. So we can say that this is like 4k minus k and 8k. Alright, so PR is going to be something like this. So the magnitude of PR is going to be 4k all squared plus minus k squared plus 8k all squared, and that's equal to 18 squared. That's going to be 16k squared plus k squared plus 64k squared equals, what's 18 squared? Equals 324. Okay, so that gives me 16 plus 64, that's going to be 70, that's 81 k squared is equal to, let me put that a bit neater, 81k squared is equal to 324, k squared is equal to 324 over 81, so k is going to be equal to 324 divided by 81, that's 4, so k is going to be plus or minus 2. So that means P to R can either be 2 times 4 minus 1, 8, or it can be minus 2, 4 minus 1, 8. Sorry. 4 minus 1, and what am I doing? Writing downwards. 4 minus 1 and 8. Okay, so PR can either be one of those two, right? So we want to find the position points of possible positions of R, so we can go from O to P and then P to R. Okay, so now we found the vector P to R, the vector P to R dash. We can work out what the position vector of R is. Now the position vector of R is the vector from O to R, and the position vector of R dash will be the position vector will be the vector from O to R dash. So we've got to work out how to find those. Now what we found so far, we know what the vector from P to R is. That's 2 times 4 minus 1, 8. 4 times 2 times 4 minus 1, 8. And the vector from P to R dash is going to be 2 times 4 minus 2 times 4 minus 1, 8. That's the vector from P to R dash. We know we want to find the vector O to R dash and O to R. These are the two vectors we want to find. Okay, those are what we want to find. Now O to R is going to be O to P plus P to R. So O to P plus P to R. That's O to P plus P to R. And O to R dash will be similarly O to P and then from P to R dash in the opposite direction. Okay, so we're going to go from O to R. We want to find the position vector of R. We go from O to P and then from P to R. We want to find the position vector of R dash from O to P and then from P to R dash. Okay, which is a vector like that. Alright, That's P to R. So now we can find those because we know the vector O to P is 2, 3, minus 7. Okay, that's the position vector of P. So we know that's going to be 2, 3, minus 7. 2, 3, minus 7. And for P to R, it's going to be plus 2 times 4, minus 1, and 8. And from P to R dash, we're going to go 2, 3, minus 7. So we end up at P. Then we go in the opposite direction. So instead of plus 2, we're going to have minus 2 times 4, negative 1, 8. So this is going to give you 2 plus 10, 8, sorry, which is 10. 3 minus 2, which is 1. Minus 7 plus 16, so that's 16 minus 7, which is 9. Okay, so that's going to be the position vector or the coordinates of R, or R dash of R. It doesn't matter, they both could be called either, but the position vector of R is 10, 1, 9. That's one possible position or coordinate of the point R. And the other possible coordinate would be 2 minus 8, which is negative 6, 3 plus 2, which is 5, and minus 7 minus 16, which is negative 23. Okay, so the other position for R possibly would be negative 6, 5, and negative 23. Okay, and there we have our two possible positions or coordinates of the point R. They ask us to give it as a coordinate. Yes, the coordinates of, so we give it in coordinate form. And there's the answer to question number 6, part D. Okay, so I hope that was clear. It's quite long question, but it's not really that difficult, really, to be honest. You have to just make sure you keep a very clear diagram that you draw. It's a bit of a mumble right now, but in the beginning, hopefully, you could understand how it built up to give you what we ended up with in the end. All right, this is important. This is used a lot in mechanics as well, where you have to find the exact value of angles, and instead of finding the angle, you can just find the ratio. It makes things easier for you and give the answer in exact form as they want, so instead of decimal form. And there we have the answers. So other questions from this particular paper can be found in the playlist that will appear over here. Other questions from the topic of vectors in the playlist over here. You can subscribe to the channel by clicking on this link over here, and the link here will take you to a video which shows you how to find things on my channel and find the index documents and stuff that will help you. Thank you for watching, and see you soon.